Okay, we've got 1:30, so why don't we get started? Good afternoon, research methods. Welcome to week number 12. I know that today is the 11th, but this is actually the 12th week. And so we've been going at this thing for 12 weeks. Looking forward to talking about complex designs. And I want to start out with a thank you. I noticed that today, if I take a peek at my YouTube video statistics, I see that there are 19 views. I know that I watched this twice. I watched it immediately after I put it up, and I watched it just a little while ago. And so it looks like we've got a good number of people at least clocking in. There are some further statistics that I haven't checked out that tell us how long people have been watching the videos. So it will say, for example, that of the 19 views, 10 of them are less than 5 minutes long, right? And so forth. But anyway, this is good news that we're making progress in getting this viewed, I believe, before we come into class. So thank you for your good work on that. Okay, we have lots of new topics to talk about today because complex designs are in fact complex, as you saw in the video. And I want to make this as interactive as possible. I usually do. And so this is going to be our mantra for today, as it was for the other day. Can we all say this together? When I teach, I learn. Everybody? When I teach, I learn. So we're going to spend some time working in pairs, and then we'll see if we can open up from beyond that and see where the confusion might still be. But this is a great way for us to practice, right? We try to get the lecture by way of video, and then we use this time as rehearsal time, just like the blue coats like to rehearse. We're going to be rehearsing today. So what I'm going to do is this. I'll open up the PowerPoint lecture notes from 11/11, so we're right on track for today. And the way I've divided this up is I think that the first let's say 9 slides or so are largely on one topic, or at least there's some coherence there. And so what we'll have you do is work with your partner, teaching your partner slides 1 through 9, and then you can switch after a couple of minutes, and you can play student while your partner plays teacher. So we'll give you the chance to be student and teacher in these 5-minute intervals. And then after 10 minutes, we'll come back to the main group, and we'll let somebody teach me about what's going on in slides number 1 through 9. Okay, we'll do it that way. So let's see if we can really mix up the groups today. Maybe I'll take some people from row 1 and mix them with row 3. So we'll have people move around just a little bit. I wonder if we can have Mira come on up and join Marin. And Sasha, can you come up and join Nina? And then why don't we have Maddie go back and join Giselle, and then we'll have you two be a pair. How about that? Okay? All right. And then can we have Hannah go back and join Kip? Jenna, can you come up and join Catherine? Okay? Meg, can you go back and join Natalie? And I wonder if we can have Katie go back, all the way back, and be with Brittany. Okay? Oh, sorry, did I say Meg? I'm sorry, you started over there. I've been calling you Meg 3 times. So Katie, can you go to, where did I, okay, back to Natalie, okay? Well, okay, sorry about that. And you two are a pair. Very good. Sorry about Meg and Katie. All right, very good. Please mix it up, and we'll have you go for 5 minutes. And then after 5 minutes, we'll switch. So we're doing slides 1 through 9. You'll be teacher for 5 minutes on these 9 slides. Uh-oh. That's okay. Just slide over another chair.
Okay. Slide it under the chair. I'm not really quite sure.
That's okay. That's right. That's all right. Just slide it. Just put it underneath.
Got it. It literally just went.
That's really funny.
Slides 1 through 9.
It doesn't matter.
Alright. So we know
follow it more than the last video. I do too. Yeah. So maybe the analysis could have proposed to that. Interaction effects? Yeah. So that's like, do that. And it's like different depending on the levels of the graph. Right? The interaction effect.
What about the interactions?
It's like independent variable, different depending on the levels of a second.
Yep, that's what you've got there. Sounds about right. Okay.
Describing the graph, independent variables on the ordinate is plotted in this graph.
And then there's three levels. So the next graph would be this graph.
So, like there's three ideas of there are three levels of
You're right. Okay, well, one idea is level and there's one idea
proportionality versus disproportionality. And the disproportional one, the ratio between like male and female
analysis is find out really you've got your
So we're only doing slides 1 through 9 for the moment. Okay, if people have made progress on 1 through 9, can we switch? So you're still doing 1 through 9, but when you come to a convenient switching point, can you play teacher if you played student and vice versa? Switch roles.
in most of the groups.
So how like so see, like these are the three levels, right?
Yep.
How would we identify the conversions? I can't say that.
Conversions? Okay.
How would do we say that it's like of each of those levels there are 2 levels to define those?
So this variable has 2 levels, that variable has 3 levels, right?
Oh, so Oh,
Okay.
I think I get it.
Okay. Okay. Okay.
I'm gonna say that that's two parts before now.
You can also look online if you prefer to have them larger. Okay.
No, that's independent variable.
Let's go for one more minute, and then we'll see how we do.
I think this computer's still broken, but this
Sorry. Okay, maybe we can have you look on over here. Right. I'll also project up here. Just a moment. Okay, sorry to interrupt. Why don't we come back together and we'll see what people have to say about these. We'll stay with slides number 1 through 9, and we'll see how people have made their progress here. So I wonder if maybe we can have the group just yell out the answer to the first pop quiz. What's a synonym for complex designs? And you can stay where you are if that's all right, because we're going to do several of these. So it's all right if you want to stay in your seats. So this was a factorial, and we're going to use those terms interchangeably. What is the simplest kind of complex design? Wow, okay, really good, really good. So the answers are so much more robust when we have you working in small groups first, I think. And can somebody explain the primary advantage associated with complex design? Maybe we can yell that out in one word? Interaction, okay, really good. Anybody want to, we didn't say a lot about what an interaction was at this point in the video, but anybody want to give us a little foreshadowing of what that means, an interaction? Or maybe an example? Who can help us out with that, what an interaction is? Thank you, Jenna.
You don't have, when you're looking at independent variables and dependent variables, it's not often that you have one thing related to another without anything else having that interaction. It's life is more complex.
Okay.
And so interaction is the idea that there might be more than one independent variable that are working together to have an effect on the dependent.
Excellent. Okay, so out in the real world, and we are thinking about behaviors, thoughts, and feelings. That's what brought us here into this class. We're trying to understand how the real world is operating, and we might have to create a research representation. So far, up until this point, we've been doing one variable at a time. We've had one independent variable at a time. That's not a bad way to get started, but probably the real world is more complicated than that. When we have multiple independent variables, we have complex designs, which we also call factorial designs, and we do these primarily so that we can look at interactions which we know are going on in the real world. Now, one downside about all of this is that usually there are many variables that are interacting with one another, and frequently in various designs we look at maybe 2 or 3 at a time, something like that, which is better than looking at 1 at a time, but it's not maybe as good as looking at 30 or 40 at a time, which is maybe what we need to be doing. And as we get into today's conversation, you'll see how difficult it is to look at even 2 or 3 at a time, but at least it's a step in that direction. So that's our motivation for doing this. It gives us maybe a better representation of the real world. So really good responses. Okay, let's see if we can go just a little bit further. And we got to this bit where we're setting up some of the graphs that we might use for our regular designs that have just one independent variable, and also for these complex designs. So can somebody describe how the variables are plotted in this graph? We have a script that we go over in the video. Anybody want to help us out with that? It starts out with, in this graph. How does that go? Okay, thanks, Katie.
In this graph, motion sensitivity is plotted in a function of
Perfect. In this graph, motion sensitivity is plotted as a function of hue condition. Our generic script is in this graph, dV is plotted as a function of IV. Can we all yell out how many levels the IV has here? Has 3 levels. Okay, so this would be, if we were to do some kind of statistical analysis on this design, we would have a one-way analysis because we have one independent variable and they are valid Q, no Q, and invalid Q. Okay, can somebody else help us to describe the variables in this graph? Somebody do that for us? We have a script that we've elaborated on. Anybody want to get us going on that? Okay, we'll go with Natalie. Thank you, Natalie.
So in this graph, discriminality is plotted as a function of task with training as parameter.
Excellent. Okay, in this graph, discriminability is plotted as a function of task with training as the parameter. Okay, so this is now a script that we can use to begin to describe a complex graph. A complex because it has more than one independent variable. So how many levels do we have of each variable here? Let's all yell it out. The dimensionality of this is 2 by 3 or equivalently 3 by 2. Okay, so that is to say that we can talk about having a 2 by 4. It's 2 inches this way and 4 inches that way. That's the dimension of that piece of lumber. We also now can describe the dimensionality of our research design. In this case, we have 3 levels of the task variable. We have 2 levels of the training variable. Okay, and the one that has the different colors is the one that we sometimes say is the parameterized variable. Okay, so that's a little bit of new terminology that we introduce once we start increasing the complexity of our design. Okay, let's pause and see who's okay with that. Is anybody confused by any of that? No? Okay, that's looking really good. All right, let's go a little further. Can somebody help describe this one? Maybe you can give us a script for this one, just as a little bit of practice. I don't do this one in the video. I think I don't do this one in the video. I think I shoot past it so that the video doesn't take up too much time. Somebody else want to walk us through that script? Okay, thank you, Jenna.
In this graph, mean duration of eye contact is plotted as a function of gender pairing with conversant, or with
Yeah, that's right. It's conversant.
place conversant as parameter.
Okay, perfect. Right. So in this graph, mean duration of eye contact, which is measured in seconds, is plotted as a function of gender pairing with conversant as the parameter. What is the dimensionality of this one? Let's all yell it out. 2 by 3 or equivalently 3 by 2 because we have 3 levels of one variable, 2 of the other, and we don't have a particular convention for saying which one comes first in our description of 2 by 3 or 3 by 2. Okay? All right, so now we can talk a little bit about how these variables are designed. By the way, here's an independent variable, and it could be the case that the different levels of the independent variable are administered within subjects or between subjects. Okay, that could be true for our x-axis variable. Same thing for our parameterized variable. It could be the case that that's administered between or within subjects. At this moment, we haven't said whether it is between or within. As we get into complex designs, we'll start out with the between subject case in most instances, and then we'll make our way to a within subject case, and maybe where we have one of each variety of variable. Okay, here's an oldie but goodie. Which graph is messed up? Let's all yell it out. Real loud? The right one? Okay, and why is that? Can somebody walk us through why that's messed up? Okay, we'll go with Meg.
Because the ordinance doesn't start at 0, so then you get a disproportionate view.
Okay. Yeah, really, it's the one on the right, okay? It does say disproportional here, and the reason it's disproportional is it doesn't start at 0. And just to think that through, in the real world, if you had maybe 1,000 adult males selected randomly and 1,000 adult females selected randomly, and you average their heights, the males would probably be taller than the females on average by about the margin that you might see there. Right? Men would be slightly taller. Men would not be twice as large as women, right? And that's what this graph would suggest visually. So beware of slick salespersons who are trying to sell you something, and they've got maybe this kind of an actual difference between themselves and their competitors, and they're making that difference look a lot bigger by having maybe a misrepresentative graph not starting at 0. Who's following that? Yeah, I think we've done that one before, an oldie but goodie. Okay, all right, really good. Questions on any of that before we move forward into the next set of slides, and I'll ask us to look next time around at slides number 10 through 24 with the same partner that you had just a moment ago. And now we start getting into the analysis of this, and it gets a little bit tricky. So we'll give you 5 minutes to play student, 5 minutes to play teacher, and then we'll come back and talk about it as a group. So slides 10 through 24, and we're now dealing with the analysis of complex designs. Go ahead.
About the overall characteristics.
Figuring out. So when you're considering each other's, we're looking at, for example,
Levels of that.
we might have two levels of factor A and two levels of when we consider more trouble.
You're going to focus on one, that's what it is. Factor B goes away. So you're back to one and this other factor two level. Because we're taking out factor B, which is like this side. You're focusing on so if A goes in, you focus on B, which is what's regardless of the thing, you have to like look at them as a different thing. You're only I'm going to take an average and like that's when you're comparing them to each other without looking at the two separate before and after. So if you average out these two bars,
Does that work for you? Okay. Who follows that? Who follows that? Okay, so we have parallel lines, and when we have parallel lines, we have no evidence for an interaction. So Kip and several other people in the room were correct for putting up 2. And Hannah has a question, please.
My question is the break in the graph at the beginning.
Okay.
We said made more messed up. That doesn't matter when you're doing parallel lines.
Yeah, it won't matter when you're doing parallel lines. Now, this would matter. Why would this matter? Can you help us out with? So we do have a break here. At least this time we're being honest about that. We're saying that we have a break. And what does that tell us when we have the break? It's not proportional, right? So that's a separate problem that we might have with this. But it's still the case that these are going to be parallel. Okay? Good question. Very good question. Okay, so why don't we go on to yet another piece of information we can pull out of the same stimulus. In this case, this graph is our stimulus. And then we want to see if somebody can describe the main effects. Okay, so before we get into answering that question, is there somebody in the room who can define for us what the main effects would be in this graph? There are going to be 2 of them, right? There would be the main effect of this and the main effect of that. What are the this and that's in this graph? The main effect of... Go ahead, Ming. Perfect. The main effect of task, because that's one of our independent variables, and of hemisphere. That's our other independent variable. So whenever we have a 2 by 2, and maybe it's a, if you will, a factor A by factor B, we can always ask, what's the main effect of factor A? Maybe that's the one on our x-axis, and the one that's parameterized or shown in different colors is our factor B. Okay, so we'll let you look at this for a moment. And now why don't we ask the question about the task variable? That's the one on the floor. And we'll ask, do we think there's a statistically significant main effect for task? If you think there is, yes, a significant effect, please put up 1 finger. If you think there isn't, put up 2 fingers. If you're not sure what I'm talking about, put up 3 fingers. So is there a main effect of task? Okay. Is there a main effect of task? We'll let you think it through. Okay, and I think Jenna was probably the first to respond on this one, and I think that's the correct response. She's putting up a 1. She thinks there's a main effect. Can you describe what you think you're seeing?
Yeah, so for type of task, you want to look at spatial
Okay.
versus verbal. So
Good.
you want to look at the grayish bar and the purple bar together and
Uh-huh.
kind of mentally average those out.
Okay,
And then do the same with verbal.
Uh-huh.
The spatial bar is still higher than the verbal.
that's right. If we took the average of these 2, because main effects is all about averaging, we can just eyeball it and say that they'd probably average out to here-ish. Okay? And then these 2 would average out to here-ish. So it looks like the spatial task is generating more errors than is the verbal task. Errors, again, would be our dependent variable. So we're getting more on this side than on that side. Who's following Jenna's logic? That was actually correct logic. Okay? And so she gave us, by averaging, she gave us the main effect for task. One more, can we now extract the other variable that Meg referred to, and that was the hemispheric variable. Can we now ask you to find whether there is a main effect or not of the hemisphere variable? And when you're ready to vote, 1 is you think the hemisphere variable is significant, 2 is you think it's non-significant, 3 is you're not sure what's going on here. Okay? See some different numbers coming up, and I think Hannah has a correct response. Is that a 1, Hannah? Yeah. Okay, I think you're correct. Okay, and can you just so several people in the room are not voting or they've got a 3, so can you tell us how you reasoned that through?
Actually, no.
You're not sure? Okay, all right. So 1 was the correct answer, right? And we'll just see if we can get to the reasoning for that. Can we go with Maureen? Thank you, Maureen.
I guess I did the thing where you can kind of like mentally add the bars on top of each other.
Okay.
You can see that the one for the right hemisphere is going to be a lot taller than the one for the left hemisphere.
Okay, right. So people in the back might not have been able to hear that, but that was spot on. So thank you, Maureen. Very, very good. So what we're doing is now we're basically taking an average of the dark bars, and who's okay with the idea that the dark bars are going to have a higher mean than will the light bars? People seeing that? So now we're collecting like terms as we always do, but we're collecting them according to the hemispheric variable, and we have to compare the right fraction of errors to the left fraction of errors because the number of errors that we have here is going to be our dependent variable. She mentioned something else that I mentioned in the video, so thank you for listening, Maureen. If averaging is difficult for you, you can pretend that these are Tinker toys and just stack one on top of the next. So if you're going to stack that one on top of that one and create, if you will, a purple tower, and then you stack this light gray on top of that light gray, you'd have a light gray tower. Who's okay with the idea that the purple tower would be taller than the light gray tower? Does that work for us? Okay. So, and it wouldn't really be that close. I mean, they would be pretty noticeably different. So we could be at least moderately confident that we'd have a significant effect of hemisphere. And specifically, we could say it looks like the right hemisphere is generating more errors than is the left hemisphere. Okay. So not only do we know that there's an effect, we know the direction of that effect. Okay. Who's all right with all of that? All right. All right. Really good. Let's see. We've got a moment or so. Why don't we do just one more and we'll see if we can drive this home. We'll go to here. So these are now the same variables, okay? Same variables, but they've now changed the data around, right? So they're plotting the same parameters and all of that stuff, but they have slightly different data values in there, okay? So let's take a look at this and ask the first question. Vote with 1, 2, or 3. Do we think we have an interaction in this graph? Okay, I see a sea of 1s. Brittany, can you help us out? That was the correct response.
I'm looking at doing the stacking again.
Okay.
And it seems so they would be, my mind's making sense right now.
Okay. Okay. It's hard to put in words. That's all right. Not sure we want to stack. I think what we want to do here is connect the like terms. So we go gray to gray, and that's downward. We go to purple to purple, and that's upward. We go crisscross, and now we have something like this, and we get a pretty strong interaction. How many people have that? Okay, real good. Why don't we go on to now, we'll finish off with these two. We'll look at the main effects. Is there a main effect of type of task? Yes, there's a clear effect. Nope, not a significant effect, or don't know. Okay. I think Meg's got it. What do you think, Meg?
I'd say no, because when you average out the two bars together, one for spatial, one for
They're pretty close, right? Yeah, so this averages out to there. Here is the average roughly. They're looking pretty close. We're probably non-significant, right? Okay. One last one, and I'll do this one for you. If we now look at the main effect for hemisphere, what we can do is start stacking the bars, and we take an average of these two and an average of these two, or we can stack them up, and probably the purple bars would be taller than the white bars, but it's not really, really clear. There might be a significant effect, maybe by the hair of its chinny chin chin, because the purple ones are slightly taller than the others. Who's okay with that? All right. Thank you for a really great session and very interactive session. I look forward to chatting with you tomorrow more about this one. We'll finish this one off, and we'll also go on to our brand new video where we talk about simple effects and also hypotheses. See you tomorrow.
Sorry, my phone kept going.
Oh, that's okay. I thought I heard that once, then I ignored it, and then I saw people were spinning around. I thought, there it goes.
I still have to show you who you are. I always remember it. Oh yeah. No one. Because I can't. I know. I'm supposed to say I have to go to Hill and then left all of the like this. I have to like lick there. I want to sleep. Snack and boo.
Hey, Brenda, how are you? All right. Is this your 200 level research course that you're in these days? Okay. Ah, really good. Really good. You're probably starting to get ready for a poster presentation in a few weeks. Is that right? Are you going to be doing? Yeah, great. We look forward to those.
Yeah, like if you're focusing on training, there's only two. But you're not comparing and so then you can still see because like I don't have much time to do this. I couldn't
So interaction is what's like.
Yeah, so
I didn't have much.
Say we like have a secret
and then we're only going to get green when
Okay, why don't you switch when you're ready? When you get to a convenient stopping point and switching point, switch teacher for student.
yeah, very same sort of idea.
So this is like what we're looking at, but that's like a graph.
I feel like if I can remember, it was like actually
Very different than
because I was just doing this.
and then like
Like averaging your
as a 2 or 2 by 3, but if you make it 2 by 2 by 3, that's usually independent variables.
Okay, and the main effects of that. So say there's hemisphere is high, and it would be 2 levels and then fast would be 2.
Yeah, so that way you could see, I mean, otherwise if you have them all together, you might not see like this, that, then it's really just an this, you can see that. So it's a I wrote down.
Okay, why don't we do one more minute, and we'll see how people are checking in. Okay, why don't we see if we can get back together as a big group. You can stay right where you are. We'll do one more set of exercises. We'll do slides 25 through the rest in just a little while. But why don't we have some conversation about how we begin to analyze these complex designs. And before I go to the next slide, maybe somebody can just tell us that when we got to this point in the video, or the next slide in our PowerPoint presentation, we said that as we are talking about analyzing complex designs, there are sort of 3 main ideas that we're going to be getting to. And we get to 2 of them here, and then we get to the 3rd one in the video that you'll be watching tonight for tomorrow. Anybody want to tell us what those 3 big ideas are? Okay, thanks, Mira.
Main effects, interactions, and simple effects.
Yeah, main effects, interactions, and simple effects. So even if we have a relatively simple complex design, even if we have this 2 by 2, we're still going to have a couple of main effects. We're going to have an interaction effect, and we're going to have a simple effect. At least in principle, we could have all of those going on. So there are different varieties of effects that we're going to be looking at. And when we're talking about an effect, we're typically looking for some kind of a difference. Is that variable driving a difference in the dependent variable in some way? Okay, so we'll be talking a little bit about main effects. And I wonder if somebody maybe is able to summarize what we're describing here in the main effect. Maybe in your own words, can somebody try to teach me as if I were your student? What do we mean when we're talking about main effects? Anybody put that in their own words? Okay, we'll go with Meg and then with Mira.
What I took it as is that when we're like looking at a graph and we have how we said like in the graph like the dv is plotted as a function of the IV with like blank as parameters. You either take like one of either the IV or the parameter, which would be like the second independent variable. Only one of them, you're looking at like only that. So I describe it like while looking at the graphs, like if you have if it's like a 2 by 3.
Okay.
And you have like a black bar and a white bar right next to each other for the 3 levels of one of the independent variables, then you either look at like the 2 bars as like together, like the average of one of them.
Okay.
And you don't consider like the 2 separate bars because
Okay.
that's like the other
Yeah.
one.
Okay.
Or you just look at them like compared to each other, the black and the white bar
Mhm.
for each, rather than comparing them.
Okay, yeah, that sounds really good. Do you want to add anything to that, Mira, or say it differently, or was that about what you had to say? Okay, really good. What we wind up doing when we're looking at the main effects, we are simplifying the complexity of the design. We'll stay with Meg's example of a 3 by 2, and we can just look at the data as if they had been just a one-way analysis, and maybe we'll look at the one variable that has 3 levels. After that, we can look at the one variable that has 2 levels. Here's what's critical, and it might have just gone by, or maybe you're not really seeing it. What's really important here is that we do this collapsing by way of averaging. And I hope that you'll emphasize that. The reason why that's going to be important is tomorrow when we talk about simple effects, we will also begin to simplify the design, just like we're doing today. We're taking the 3 by 2 and we're cutting it down to just maybe a one-way that has 3 levels or a one-way that has 2 levels, and we're cutting it down by engaging in this averaging. Tomorrow we're going to cut it down using simple effects through some mechanism other than averaging. So those were all really good descriptions that we have, and we get to that simplification down to just one variable at a time by engaging in averaging. and Meg was correct that we might average over all the white bars and compare them to the average of the black bars, or within one of the levels of our task variable, we might average across the black and white bars to come up with a direction component, a luminance component, and a speed component. So we can average these two together, these two together, these together. We'd have those three averages, and we're now down to a one-way that is only looking at task. Who's following that? Is that working for us? Okay. So that's one of the analyses that we could do, right? And we're going to get to that simplification just by averaging. Okay. So let's take a look at this, and we'll see if we can vote maybe with our fingers, and we'll see if we have 1 means sig, 2 means non-sig, and 3 means I don't know what this guy is talking about, as always. Okay. So why don't we take a look at this, and we'll see if there's a main effect of training here. And what we mean by that is there a significant effect for training? We'll let you look at this graph. We'll let you do some mental gymnastics on this using the averaging that we talked about a moment ago. And we'll let you vote. If you think that when we're taking these data into consideration and we're looking at the main effect of training, if you think we'd have a statistically significant effect, please put up 1 finger. If you think we wouldn't, and that effect would be non-significant, put up 2 fingers. If you're not sure what we're doing here, please put up 3 fingers. Okay, so we'll let you do the mental gymnastics on this and vote when you're ready to vote. It does take a little bit of time, so you shouldn't feel bad about thinking it through. And by the way, the really, really good answer to this comes when you actually run it in SPSS, but hopefully we'll be able to pull out some information just by visually looking at this and coming to a conclusion that yes or no, or maybe we don't know what's going on. Okay? I think I see a few people voting. And why don't we see if everybody, if you're not quite ready to vote, that might mean that you're at number 3, you're not quite sure how to do this. Why don't you put up a 3 or a 2 or a 1? We'll see if we can maybe force a vote. And I see a couple of 3s coming up. Very good, several 3s. And I think that Kip had an early 1, and why don't we go with Kip? 1 I would say is probably correct.
Right, I'm not really sure, but just think about averaging that.
Okay.
Like if you were to average, I'm not really sure what you're supposed to average.
Okay.
If you were to average like the before and after direction training.
Okay.
The direction, like average bar would be higher, significantly higher than the speed and luminance.
Okay. All right, so that would be one way of averaging. We're thinking about here the training variable. And so how is training shown on the graph? By 2 different colors. We've got the black color and the white color. Black is for before direction training. White is for after direction training. Let me pause there. Who's okay with that? Anybody remember the phrase that we recalled from the video? We harkened back to maybe 7th, 8th, or 9th grade algebra. What did we say that phrase was? Collect like terms, okay? And what we're going to do now is we're going to be averaging across like terms. So if you will, the white bars are like terms to each other because they're all occurring after direction training. The black bars are like to each other because they are occurring before direction training. Who's okay with that? Okay, so I think we're most of the way there, but I wonder if we can now just take a mental average of all the white bars. Okay? It's hard to do, right? I mean, you just might say, what do you think they would average out to intuitively without actually jotting down the numbers? Maybe we can develop intuitions about this. The class is about quantitative reasoning. Okay, I know that you could put together 3 numbers and add them up and divide by 3. We learned how to do that many, many years ago. Hopefully we can take a mental average of that and see that the white bars would probably have a higher mean than the black bars would. Who's following that? Is that working for us? Okay. And to the extent that the white and black bars would be different from each other on average, then we might say that discriminability is higher after training than it is before training. There's probably an effect of that training. We're getting greater discriminability after training than we are before training. Who's okay with that? Notice that that statement doesn't say anything specifically about the direction task, the speed task, or the luminance task. Right? We kind of got rid of that variable just for the moment, and we simplified the design only to talk about how is performance before versus after training. Who's okay? Is that working for us? Who's got a question on that? It's okay if you do. Please go ahead, Mira.
So for this graph, because we're trying to find the effect of training, we measure all of the white bars together, and then for the next one, we do the individual.
Oh, I was going to ask the class to do the, yeah, I think you're there. Can we ask the class to do what Mira was about to start doing? Can we now ask about, if you will, I'll call it factor B, is there a main effect of task? Okay, so we'll let you think this through, And by the way, Mira, I don't know if everybody saw that, but the way you just gesticulated with your hand was correct. So I think that you were on a good start there. So the question on the floor is there a main effect of task? That's our other variable. And we'll let you think it through. Do your mental gymnastics when you're ready to vote. 1 is, yes, I think there's a significant effect of task. 2, nope, task is non-significant. 3, I don't know what this guy is talking about. So again, when we're talking about main effects, we're simplifying things, and we're simplifying by averaging. Another clue is we're going to collect like terms. Okay, I think several people are voting, and I wonder if I could, Rachel, is that a vote for 1?
I think so.
Okay, all right. Okay, what kind of reasoning do you have going on, Rachel?
Because are we comparing like direction, speed, and movement?
Okay, there's a sense in which we're making that comparison, right?
So direction is a lot like bigger.
Okay, you're correct that direction is bigger. How did you come to that? What did you average to get to that?
Bars.
Which 2 bars, real quick?
The black and the white bar.
Okay, so we take the average of these 2, then that mean is going to be very crudely something like here-ish. Okay, we don't even have to give it a number. Just that guy and that guy center out to about here. Okay, and this guy center out to something quite a bit lower than the direction pair averaged to, and this one averaged to something substantially lower than direction. Okay, who's following that? So always we collect like terms. How do we define like terms? Well, it depends on which variable we're analyzing. If we're analyzing the main effect of task, we have to find the terms that share direction task, the terms that share the speed task, the terms that share the luminance task. If we're talking about the other variable, in this case it was the training variable, we might say, well, which of these bars shares the before training condition, which of the bars shares the after training condition? Okay? Who's got that? Yeah, this requires a lot of work, a lot of mental gymnastics here, but I think you did it really well. Okay, now the fun begins. So those were main effects. That was our first pass through main effects. Let me pause there and see if we have any questions on main effects. Okay, and take some mental gymnastics to do that. Okay, interactions. So we're still within the slides that we were trying before. We were doing slides 10 through 24 as we were playing teacher and learner. And now we're up to slide number 15. So some idea about what an interaction is. Anybody want to try to put that in their own words, at least roughly? And it's okay if it overlaps a little bit with what's going on here. Thank you, Jenna.
Well, so an interaction happens when one of the independent variables is like connected to the level of the second variable. I don't really know how to describe it, but like for example, not that it's lethal like the one you said in the class, but like some like antidepressants make like birth control less
efficacious. Okay.
Because they are interacting in some way, and so yeah.
Okay, right. So the combined effect, and that's another way of thinking about this. And one of my colleagues always makes this gesture. The combined effect is what we're talking about when we're dealing with interactions. I think Meg also had something to contribute, or maybe.
This is correct. But I put in the way of where like you're like using like screen printing colors, and like you can't get green without doing blue and yellow.
Okay.
So like if you don't do the blue first, like it depends on that. Like you have to pull the blue.
Okay.
In order to pull the yellow and get green.
Okay, really good, really good. I think that's a very nice description. So the idea is that the overall effect depends one more time on the combination of variables, right? So we couldn't get there. We could run lots of studies where we looked at the effect of green in Meg's example and the effect of, was it green and blue, or I'm sorry, which colors you had? Blue and yellow? I'm sorry, blue. We could look at the effect of blue and we're not going to get very far. The effect of yellow, we're not going to get very far. But the combination is really different, and we can only understand that by pulling them into the same study. Okay? And that turns out to be the case in many behavioral studies, and might be the case also in lots of biological studies. So the interaction is what we're shooting for here. Okay, now let's see if we can make some sense out of interactions. This is a little bit more difficult. And we have at least one method that's something about parallel lines. Can somebody help us out in understanding what we do with parallel lines when we're trying to look at these graphs and get to the second component? We've already done main effects, so now we want to go to interaction effects, and Katie's got something for us.
Well, if the lines are parallel, I think there's no interaction because the variables are literally not intersecting.
Okay.
If they're intersecting, that means there's like perfect
Okay, really good. Yeah, that's interesting. I've never heard a student say intersecting, but that's actually a good way of thinking about this interaction, that if you have these parallel trends, they would never intersect with one another. But as they begin to bend one toward the next, they would eventually intersect, and sometimes they're very strongly intersecting. And that's a good way to think about whether we have an interaction inside of our data set. So why don't we go to a particular example, okay? And we'll use this schema one more time. We'll use the 1 is significant, 2 is non-significant, 3 is I'm not sure what's going on here. First, just to make sure that we're all on track with this, I wonder if we can have somebody walk us through the script here. So if we had a script to describe this graph, in this graph, all kinds of noises going on. Oh, that's your phone? Maddie, if you would be so kind, either pass that forward or this. Okay, can somebody walk us through the script here? It starts out in this graph. Okay, thanks, Natalie.
In this graph, the mean number of errors is plotted with hemisphere.
Wonderful, thank you. Okay, so that's a beautiful description. What is the dimensionality of this graph? 2 by 2? Okay, we have 2 levels of the task variable. In this case, there's a spatial task and there's a verbal task. And then we have 2 levels of our hemisphere variable, left and right. Okay? All right, so let's see if we can do it this way. Let's see if you can do some mental gymnastics on this and see if you can answer the question, is there an interaction in this graph? If you think there is a significant interaction, you should put up 1 finger. If you think there's a non-significant interaction, or that the interaction is non-significant, you can put up 2 fingers. If you're not sure what's cooking here, please put up 3 fingers. All right, so we'll get everybody to vote. And it's okay to put up any number that you think that represents your train of thought at the moment. Okay, good, good. I see a few people honest enough to put up 3s. Thank you for putting up 3s. And I see some other folks putting up 2s and 1s. So we have everything here, a little something for everybody. Let's see who's got a, there's a 3. This Katie has a 2, okay? So, oh, that's a 3. I'm sorry. Okay, sorry about that. Okay. Let's go with Kip again. Kip's got a 2, I think.
Yeah.
Okay.
I said there was no interaction because the lines would be parallel.
Yeah, it's difficult to describe. You have to do some mental gymnastics. The lines would be parallel. Can you tell us how we would draw the lines, Kip?
Yeah, if you go from like the top left corner of that purple looking bar.
Okay.
To the top left corner of the gray looking bar to the left.
Okay, so here to here?
I don't know.
Oh, here.
Here are the 2 bars.
Yep.
This top left
Huh?
corner to this top left corner. That one.
Okay.
Like that way.
Ah.
Is that not right?
Either way, actually connect this bar to that bar, okay? We can get on the corners if we want to, but wouldn't change very much.
In that case, it would be parallel this way between like the purple looking bars and the gray looking bars.
Yeah, okay, so for those of you who can't do it, he's actually giving us the perfect, even if I'm not copying him, he's got it just right. If we draw that line, in other words, we're connecting like terms, okay? We're going purple to purple, and we're getting something like very roughly a 45-degree slope downward, okay? And then we're going light bar to light bar, and we're getting maybe 45 degrees again. I might not be exactly 45 degrees, but I think you can see they would be at the same angle headed downward. How did I do, Kip?